Okay, this is Unit 5.5 notes, factoring polynomials. Okay. So first up here, we have a flow chart to show us the steps in the order we would go in order to factor this. Okay. The main thing here is you have to know to always start off by taking the GCF, and then depending on how many terms there are is where we're going to start. So for example, 3 terms, we're going to start by using the AC method. If there's 4 terms, we're going to start by factor by grouping. So let's look at example 1. Okay, so we have 2x to the 4th plus 9x cubed minus 18x squared. We need to first take out a GCF, and that would be x squared. If I take out x squared, I'm left with 2x squared plus 9x minus 18. Notice how I'm left with a quadratic. We know how to factor quadratics using the a times c method. Well, a times c is 2 times negative 18, which is negative 36. So that means we need 2 numbers that multiply to negative 36 but add to 9. Okay, those numbers are 12 times negative 3, because 12 minus 3 still gives us 9. So then I rewrite this as x squared, parentheses 2x squared plus 12x minus 3x minus 18. I then put these into parentheses so I can do factor by grouping and then factor out a GCF from each. So I have x squared, parentheses, I can take out a 2x, which I'm left with x plus 6. And then here I can take out a negative 3, which I'm left with x plus 6. Okay. Since my parentheses match, I can write this as x squared times 2x minus 3 times x plus 6. This is my answer to the factor. Now, let's imagine that this is equal to 0 and it's asking us to solve. So in order to do that, we're going to set each of these equal to 0. So x squared equals 0 means that x is equal to 0. 2x minus 3 equals 0 means x is equal to 3 halves. And x plus 6 equals 0 means x is equal to negative 6. Those are my 3 answers. Okay, let's look at number 2. Number 2, we have 3x cubed minus 10x squared plus 8x. We need to take out a GCF of what they all have in common. Well, they all have an x, so let's take out an x. So I'm left with 3x squared minus 10x plus 8. I can now use my AC method to factor. So 3 times 8 equals 24. So 2 numbers that multiply to 24 but add to negative 10. Those numbers are negative 6 times negative 4, because negative 6 minus 4 gives us negative 10. So we have x times 3x squared minus 6x minus 4x plus 8. Now we do factor by grouping and take out the GCF separately. So in the first one, I can take out a 3x and I'm left with x minus 2. In this one, I can take out a negative 4 and I'm left with x minus 2. So that means I'm left with x times 3x minus 4 times x minus 2. This is my factor. Now I'm going to set it equal to 0 to get my answers for x. So first I have x equals 0, that's my first one. 3x minus 4 equals 0, which means x is equal to 4/3. And x minus 2 equals 0, which means x is equal to 2. Okay. Number 3, I have 10n to the 5th plus 15n cubed minus 100n. So from all of these, I can take out a 5, and I can also take out an n. So I'm left with 2n to the 4th plus 3n squared minus 20. Notice how this does not look like a quadratic equation because it starts with n to the 4th instead of n squared. So we are going to use substitution in order to solve this. So I'm going to let x equal n squared. We're letting x equal the variable next to b. And then if x is equal to n squared, if I square x, that's the same as squaring n squared, which gives me n to the fourth. So instead of writing n squared, I'm going to write x, and instead of writing n to the fourth, I'm going to write x squared. So I have 2x squared plus 3x minus 20. Now this looks like a quadratic that I can solve using the a times c method. So 2 times negative 20 gives me negative 40. So two numbers that multiply to negative 40 but add to 3. That's going to be 8 times negative 5, or 8 minus 5. So I get 2x squared plus 8x minus 5x minus 20. Do my factor by grouping. And I can take out a 2x, so I'm left with x plus 4, and take out a negative 5, I'm left with x plus 4. So that means I have 2x minus 5 times x plus 4. However, this is not my answer, because remember, in my original problem, I had n's, not x's. Well, I know that x is the same as saying n squared. So anywhere I see an x, I'm going to plug in n squared. So I have 2n squared minus 5 times n squared plus 4. And then I can't forget about my GCF from the beginning. So I'm going to bring it down, and I have 5n. So this is my factor. And now I just have to set it equal to 0 to get each of my answers separately for n. And I'm going to go ahead and use this space right here real quick. So I have 5n equals 0, which means n is equal to 0. 2n squared minus 5 equals 0, which means I have n squared equal to 5 halves. So n is equal to plus or minus the square root of 5 halves. And then n squared plus 4 equals 0, means I have n squared equals to negative 4. Since I'm taking the square root of a negative number, I'm going to get an imaginary number. So this is n is equal to plus or minus 2i. Okay, and again, these are my answers for each. Okay, then we're going to do number 4. So let me erase all this so we can have room for number 4. Number 4, we have x to the fourth plus 10x squared plus 25. Notice we're not able to take out a GCF, but this still doesn't look like a quadratic. So we're going to have to use the substitution. But since our thing is already in terms of x, I'm just going to let a different variable take the place of x. So I'm going to say let y equal x squared. So y squared equals x squared squared, which is x to the fourth. So I have y squared plus 10 times y plus 25. Well, my a times c is 25 and my b value is 10. So two numbers that multiply to 25, so 5 times 5, but also add to 10, 5 plus 5. So that means I get y squared plus 5y plus 5y plus 25. I do my factor by grouping. And I can take out a y, and I'm left with y plus 5. And I can take out a 5, and I'm left with y plus 5. So I have y plus 5 times y plus 5. Okay. But originally, my y is equal to x squared. So if I replace that, I have x squared plus 5 times x squared plus 5. So that is my answer. Okay. But now I need to solve. So let me get rid of some of this up here so I can solve. Let's move this whole thing up here. Okay, now I'm going to set them equal to 0. But notice they're both the same number, so I'm just going to set one equal to 0. So x squared plus 5 equals 0 means I have x squared equal to negative 5. which means I have x equal to plus or minus I square roots of 5. Because when I take the square root of a negative number, I get an imaginary number. Okay, now let's look at number 5. Notice that the difference from the front of the page to this page is that the front page had 3 terms. That's why we went straight to doing the AC method. But now this side has 4 terms. So that means we can jump straight to factor by grouping. Okay, so I'm going to divide it into my 2 parentheses. And I can take out an m squared, and I'm left with m minus 1. And I can take out a positive 7, and I'm left with n minus 1. Which means I have m squared plus 7 and m minus 1. These are my factors. Then I'm going to set them each equal to 0 and solve. So m squared plus 7 equals 0 means that m squared is equal to negative 7. So I'm going to have m equal to plus or minus I square roots of 7 because it's an imaginary number. Okay. And then m minus 1 equals 0, I'm going to get m is equal to 1. Okay. A lot simpler, a lot easier than the front side. Okay, again, number 6, notice how we have 4 terms. So I'm going to do factor by grouping and take out a GCF from each. So here I can take out a 5x squared, and I'm left with x minus 2. And here I can take out a positive 3, and I'm left with x minus 2. So that means I'm left with 5x squared plus 3 and x minus 2. These are my factors. Now I'm going to set them equal to 0. So 5x squared plus 3 equals 0 means that x squared is equal to negative 3/5, which means that x is equal to plus or minus I square root of 3/5. And then I have x minus 2 equals 0, which means x is equal to 2. These are my answers. Okay. Now on number 7 and number 8, we're going to have to do one additional step, and you'll see why in just a minute. So again, we have 4 terms. I'm going to separate them to do factor by grouping. I can take out a 4x cubed, and I'm left with 5x plus 4. And here I can take out a positive 6x, and I'm left with 5x plus 4. So that means I have 4x cubed plus 6x times 5x plus 4. Well, this cannot be my answer because if I look at this first parenthesis, it looks like I can still take out another GCF. So that's what I'm going to do. So I can take out a 2x, and I'm left with 2x squared plus 3, and then 5x plus 4. Now this is simplified. So now I just have to set each of them equal to 0. So 2x equals 0 means x equals 0. 2x squared plus 3 equals 0 means that x squared is equal to negative 3/2, which means x is equal to plus or minus I square roots of 3/2. And then 5x plus 4 equals 0 means that x is equal to negative 4/5. Last one, number 8. Okay, again, we have 4 terms, so we're going to do factor by grouping. So for this one, I can take out a 5x to the 4th, and I'm left with x minus 2. And this one, I can take out a 25x squared, and I'm left with x minus 2. So then I have 5x to the 4th plus 25x squared times x minus 2. Well, notice I can still take out another GCF from here. So I'm going to take out a 5x squared, and I'm left with x squared plus 5, bring down the x minus 2. This is now my simplified factor. Now I'm going to set each one equal to 0, so I have 5x squared equals 0, which means x is equal to 0. X squared plus 5 equals 0, means x squared is equal to negative 5. So x is equal to plus or minus I square roots of 5. And then x minus 2 equals 0 means x is equal to 2. And those are my answers.